Okay. All answers should have been posted. That do, except for the coefficient Pascal's triangle one. Okay. So hopefully you guys are good with writing. This is kind of like what 7, 8, and 9 kind of all put together, right? So write it in factored form. So we need to know how to factor. Find any zeros. That's one of the numerators. So I think that was either 7 or 8 or somewhere in there. Basically finding the zeros. Find where it has a hole. So again, if there's the same factor, then we know it has a hole. It does say of x, so you don't really have to find the hole. You just need to find the x value. Okay, so make sure you look, guys, read what it says. Vertical asymptotes, that should be x equals. Horizontal asymptote should be y equals if it has a horizontal, but even if it doesn't have a horizontal, if it has a slant, it should be y equals. Okay, and then find the domain. And domain is anything that doesn't have 0 in the denominator, no matter if it cancels or not. Okay, and then use a graphing calculator to help sketch the graph. I don't know how much that's necessary. And then they want us to somewhat sketch it, right? So when y'all guys plug that in your calculator, hopefully you get an idea. Somebody asked earlier on, like, how do we know this stuff? So I think the first thing I would do on these is find my asymptotes. Find your asymptotes and draw those. And then if there's a hole, find out where the hole is. And then pretty much plug and chug. Plug and chug on one side of the asymptote, plug and chug on the other side of the asymptote, and kind of just see where you're at. But that's if you don't have a calculator. If you don't have a calculator. So not the horizontals, just the verticals. So when after you do the vertical, plug and chug on one side of it and go a couple spots. You can graph anything with plug and chug. You can graph anything. You don't have to know what it looks like. You just, if you plug in an X and you get a Y, that has to be a point on the graph, right? So where we typically have issues is on one side of the asymptote, right? If we're trying to find out as it approaches it, you plug and chug just on the other side. So if the asymptote's at 2, plug in 1.99 and plug in 2.01. But if you're just plugging and chugging on the graph, I'd plug in 3 and then plug in 4 and plug in -1 and plug in 0. So just kind of plug and chug if you don't have a calculator. But it said use a graphing calculator to help you. Your calculators are a little weird on sometimes how they do those asymptotes. They've done a whole lot better, the new updates on programs. If your graphs start looking really, really jagged and messed up, then you need to kind of talk to me and we'll change that, change some settings around. Okay. What questions do you have over this assignment that you said, man, I'm not too sure about? This was A part. Anything on A that may have set you guys back? A lot of you guys, I think, finished in class. Here was B, right? Long division, okay? You'll have to do a long division question on the test. You will have a slant asymptote that you will have to find. Let me rephrase that. I don't know that for a fact this year. I know 2 years ago we made the kids find a slant asymptote. Because you proved in Algebra 2, you know how to find a horizontal asymptote, although I thought that on the quiz, and apparently we didn't. But yeah, you'll have to do long division. Any of those that I need to do show anything? Y'all okay? Anything? Beautiful. The binomial, I told you guys to do every other odd. You can do as many as you want. If you had tough time with those, I recommend going back and doing the others. They're all the same type thing. Let me give you those answers. Just what the heck? Oh, I'm on highlight. One should have been 80. 5 should have been 90. 9 should have been -8. Y cubed x. I sometimes put x first. It doesn't matter what order you put those in. Right? probably put y first because the y was first here. But if you want to put negative 8xy cubed, that's okay. And then 11 was just a to the 5th. Gosh, that was an easy question. I should have picked something different besides that. 17. So we had to do this, expand this all the way. On the test, you won't have to expand one all the way. It'll be a multiple choice question. Again, this is going off of 2 years ago. It was a multiple choice question. You had to find one of the terms. Okay. So, and then you had 4 choices, and one of those 4 was 16M4, negative 32M3, 24M2, negative 8M1. Notice when it's a 4th degree, you end up with 5 terms, right? You always end up with one more term than the degree. So 21, I would think if you got 21, you should be good. Maybe not, because it doesn't have a coefficient in there. X20, negative 5x16y, 10x12y2, negative 10x8y3, positive 5x4y4, negative y5. I would look at 24 or 22 or 18 for more like the test. Because my guess is we're going to throw a coefficient in there. Uh, 17. Just look for one with a coefficient in there and more of a degree. Just as that gets a little bit more confusing. But your test question is going to be more like this, like find whatever term. Because like I said, it'd be a multiple choice question. Again, going off 2 years. Anything at all on that lesson? Anything at all? Anything over rationals? Because we're done with rationals. We got 2 more lessons, 12 and 13. 13 is a 100% calculator. Make sure you got your calculators on Wednesday. 13 is a 100% calculator. So basically, I got to teach you how to use it and what to do with it. Today's not. Everybody okay? No questions? Monday morning? Y'all good? Here we go. Number 12. Number 12. Transformations. I don't know why that didn't work. It did the other day. All right. I know you guys did transformations in Algebra 2. This is going to be, I would say, quite a bit different. I'm not for sure. I haven't done Algebra 2 in a while, but this is going to be a little different, okay? So it's going to look a lot different from what I remember. An important aspect of understanding functions is the concept of transformations. Although this course, as well as past of your future courses, we're going to study a variety of functions and their graphs. All of these functions can be viewed through the perspective transformations. Transformations will weave through everything we learn in AP Pre-Cal. So once we do transformations here, guys, they'll show up in chapters or units 2. They're going to show up in units 3. So transformations, we got to understand. The concept is the same throughout, okay? And they will provide us ways to connect the topics we learn throughout this course. So below is a table of transformations. So whatever you got to do to somewhat memorize this, okay? They're going to write it as a function. F of x, g of x, guys. Y'all about done? Hey, seriously? Okay. They're going to write f of x, g of x, h of x. They're going to write something, right? And it's going to be equal to some function. Some function, typically f of x. And then they're going to add some constants to that function. So there you see g of x is f of x. There you see g of x, f of x. Here you see g of f of x and g of f of x. So they're going to do some type of things like that, okay? And you'll kind of see that as we go throughout. In this particular one, we have g of x is equal to f of x plus k. So all we have is a plus k at the very, very end. That k is by itself. So kind of think when you see something like that by itself, that affects the y values. That affects the y values. It moves everything up or down. And that's all it does. It moves everything up or down. And if it's a positive k, it moves everything up k. If it's a negative k, it moves everything down k. And again, that will be a number for you guys. If you don't see a number all by itself, then it doesn't move it up or down. So F has a vertical translation. That's the terminology that you need to use. I don't really like vertical shift. Vertical translation is what AP likes to hear. A vertical translation of K units. So we have a vertical translation of whatever that might be. Okay, whenever you see a K all by itself, or a number all by itself. That's different than this next one. This H is not by itself, it is with the X. So if it's with the X, we know X goes left or right, that's a horizontal translation. And the trick is with this one is it's always opposite of what you think. So if that's a positive H, it actually moves it negative. If it's a negative, it actually moves it positive. Okay? F has a horizontal translation of negative H units, opposite of what it looks like. So if it is a negative, it actually becomes a negative negative, which is a positive. Okay? So if it's with the X, it's a horizontal. That only makes sense. You don't have to try to, oh, it's with the X. No, if it's by itself, it's with the Y. Because really what I can do is move that over there by that, with that. And so that's the Y, right? So this is just moving the Y up that many units. This one's with the X, opposite of what you think. This one you've done before, it's a vertical dilation. All we say is a vertical dilation, no matter if it's a half or a, let me rephrase that, no matter if it's less than 1 or greater than 1. It's a vertical dilation. So you don't have to think about a shrink or expand or close or open, or it's a vertical dilation, okay? And whatever that number is, and it's always the absolute value. So if it's a negative, you still say it's a vertical dilation of the positive. It's always a positive, okay? Vertical dilation. And then over here, again, it's with the X. This one's new to you guys, I think, from what I understand. So if it's with the X, it's a horizontal dilation. And again, it's opposite of what you think. So if that's a B, it's 1 over B. If it's 1/2, we're going to flip it. So you're going to flip that one. Everything with the X flips it. So it makes it, if it's a negative, it's going to make it a positive. If it's in front of the X, it's going to invert it or reciprocate it. Okay? And it's absolute value always also. So we don't have to, you should never say there's a horizontal dilation of negative. There's never a horizontal dilation of negative. It's always that value. Okay? Now, the last two notes down here, if A is less than 0. If A is less than 0, the one that's in front of the X. Okay, so think that this just helps me, it should help you. If it's in front of the function, then basically I can move that negative over there with the y's. I can divide both things by a negative. So now all the y's that were positive are now negative, and all the negative y's are now positive. So that's a reciprocation or a flip over the, or reflection is what they like to say, over the x-axis. Okay, if it's the number out there by itself. If it's with the x, if b is less than 0, that's with the x. That means all the negative x's are now positive x's. I'm doing that backwards for you guys. So all the negative x's are now positive x's, and all the negative or positive x's are now negative x's. So that's a reflection over the y. And so if you can know those 6 things, up, down, left, right, vertical translation, horizontal, dilation, vertical dilation, horizontal dilation, reflection, reflection. Those 6 things, this lesson's easy. Okay, those 6 things. K by itself moves it up or down. H with the X moves it left or right, opposite of what you think. A in front of the function, vertical dilates it, either this way or this way. B in front of X just the x, then that's a horizontal. I think I did that backwards. Vertical, horizontal. Okay. Here's their notes that they're just telling you again. Any transformation that affects the x will occur inside the parentheses. Inside the parentheses affects the x. Any transformation that affects the x will be opposite of what it looks like. So if it's negative, it's going to become positive. If it's a fraction, it's going to become an integer. If it's an integer, it's going to become a fraction. Any transformation outside are the y values. Any transformation that affects the y values will do exactly what it looks like. Okay. All that being said, rest of the day is examples. Here we go. Example number 1. Let g be a function that is transformed such that g of x equals 2f x minus 3 plus 1. So this is how you're going to see it. Very, very similar. Describe the transformations of this function that result in the function g. So in other words, what are we doing to f to get g? And I always do the multiplications first, just because I have it. So 2 in front of the function is a vertical. Vertical dilation, I will say by a factor of 2. In other words, it's going to shrink it by a factor of 2, but we don't say shrink. All you have to do is a vertical dilation. Then I got a -3 and I got a +1. And so the -3 will be a horizontal because it's with the x. With the x. That has to be horizontal. Horizontal, vertical. Horizontal translation by opposite of what it looks like. And I just say units. +3 units. You don't really have to put the positive sign. You can just put 3. And then we have a vertical translation. By +1 unit. Question. Yes, no, somewhat, maybe. The thing that gets students is the horizontals, opposite of what you think. And then the horizontal dilations, I think, are new to you guys. I'm not completely sure. Let n be a function that the transformation of the function is n of x is -4m to x. Describe the transformations, just like we did in example number 1. Be careful because this graph sometimes looks like it may go with that. It does not. Okay, and that's why they say this is a graph of f, just to kind of somewhat help you making sure. Okay, that's why they put n and m up there too, just to make sure that you know which one we're talking about. So we have a, do it either way, but I'll do the reflection first. Let's see, the negative out here by itself. Basically, this is the way I think of this, because we get this backwards sometimes. We know it's a reflection, I hope, because it's the negative sign. But I can divide both sides by a negative really easily. Because if I divide this by a negative, that becomes a positive. If I divide that by a negative, it becomes a negative. That means to me that all the y values that were positive are now negative. And all the negative y's are now positive y's. And so that is a reflection over the x axis. That's just the way I think of it every single, it's just common sense to me. Divide by a negative. If it's inside there, I can't really divide by a negative. It's with the x. So if it's with the x, that means all the positive x's are now negative x's. And all the negative x's are now positive x's. So that puts a reflection over the y. Rather than you try to memorize something, just think about it. All right, now the 4 does what? That's a vertical again, because it's not with the x. Vertical dilation. So translation and dilation, those are the words we got to use. Vertical dilation, factor of 4. Well, that looks horrendous, hieroglyphics. And then we got a 2. That's a horizontal. I'll try to write it a little bit slower. Horizontal dilation factor of opposite of what you think. 1/2. When it's with the x, it's opposite of what you think. Questions? Everybody okay? Dilation, translation. Remember those words. All right. Now, these get a little bit more complicated, I think. Maybe not for you guys. The graph of f of x consisting of 2 line segments in a semicircle is shown from -3 to 5. So I'm seeing it's from -3 to 5. And it includes those because they have periods or they have the dots. So it has an absolute max and it has an absolute min. It just has an absolute min like a lot of times. Okay. Sketch a graph on the same axis where g of x is equal to f of x plus 3 minus 4. This one's pretty easy because all we're doing is shifting left and right and up and down. There's no dilations. There's no reflections. So if there's no dilations and no reflections, I'm just going to take every one of those points and basically slope-wise, I'm going to move it -3 on the x, opposite what you think, and -4 on the y. So that's what I'll do. I'll go -3, 1, 2, 3, 1, 2, 3, 4. That's a new point. And I'm just going to take each point. I don't see another point until 1, 0 or 0, 1. So I'll go 1, 2, 3, 1, 2, 3, 4. And if I have to, I'll connect that. One, 2, 3, 1, 2, 3, 4. One, 2, 3, 1, 2, 3, 4. Yes. Cuss. -1. First mistake this year. Boy, sure in the heck did. You'd think I could see that. It's all right. Y'all fix it. Do it right. I can't leave that up there. Did I move it on every single one of them or just that one point? Oh, gosh darn it. I didn't think that slope would look very good. Beautiful. Yep. I always do the reflection first. I do the reflect because it's like multiplication division. You got to do order of operations. We'll do that in a second. Yippee, yippee, yo. Questions? Okay. Okay. So this one has a -h, which flips everything. This one has a 2x, which makes all the x's now, it's going to be 1/2. and then I'm positive 1 on all the y's. This is the way that I do these. I think it's the easiest. You do it however you want. Some of you guys are going to knock this out of the park. And some of you guys are going to look at it a little confusing. This is the way that I do these. -4, -3. I'm just putting a point down. Y'all okay? Just putting the points down. Next point, -2, 1. You can put as many points as you want to down. I'm not putting fractions or decimals or anything. I'm just putting points that I can see. Okay? Some of you may have to do more. Some of you may not have to do as many. I got another point at 0, -2. Okay, 0, -2. I got another point at 1, -1. I'm going to go ahead and do that. You don't have to. And I got a point at 2, 0. And I got a point at 3, 1. Now it gets confusing a little bit because now I got a hole, but then the point is down below it. So let's talk about this, not this question. Just talk about this function. Okay? This function looks linear, linear, linear with a hole. Okay? So it's a piecewise function somewhat that has an actual, just a linear function from what, -4 to -2. It's a linear function from -2 to 0. And then it's a rational function because it has a hole. The domain of that goes from -4 to 6. Solid. Okay, this gets a little confusing because a lot of times we think of the domain as where I start my pencil and where I end up. That makes it continuous. This is not continuous from -4 to 6, but it is defined from -4 to 6 because at 4, I'm defined. I'm just defined down here. Just talking about in general, has nothing to do with translations. Okay with all that? All right, so here's what I'm going to do for this one. I'm going to put 2 points. I'm going to put 4, 2, and I'm going to do something like that because that's like a hole. Just something to help remember that that's where my hole's going. Okay? And then I'm going to do 4, -1. And that's a point. And if you want to do something like that, because it's not really going to be part of my function, it's just going to be a point all by itself. And then I'm going to, I could do 5, 3, but I'm just going to go ahead and do 6, 4. Just to show you that I can skip some. Are y'all with me? Everybody okay? So those are points from the original function, which is h. Those are points from h. Now I'm going to translate those points rather than try to translate the graph. And just like order of operations, you always multiply and divide before you add or subtract. Always multiply and divide before you add or subtract. So I'm going to look at this function and I realize I have 2 things happening. I'm having a -h, which now turns all my y values that were positive, negative, and all my negative y's are now positive y's. So I'm going to do that first. So this is now going to be +3, -1, +2, +1, 0 doesn't flip, negative, negative, positive, negative. Okay with that? So I've done the reflection part of it. Reflected over the y. Yeah. Over the x. I did it back. I knew I was going to mess it up. Over the x, because all the positive y's are now negative y's. Reflection over the x. Okay? That 2 now multiplies all my x values because it's with the x, but it's opposite of what you think. So it's not going to double them, it's going to half them. So now instead of -4, this is now going to be -1/2. I'm sorry, -2. Jeez. I'm doing earlier ones before I do the later ones. Okay, so -2. Half of -2 is -1. Half of 0 is 0. Half of 1 is 1/2. Half of 2 is 1. Half of 3 is 3/2, or 1.5. Half of 4 is 2. Half of 4 is 2. Half of 6 is 3. And you might do this so that I know that I've done those. And now the +1 is just going to do what? Add 1 to all my y's. It's going to move everything up 1 unit. So I'm going to add 1 to all my y's. So now this is going to be 4. This is going to be 0. This is going to be 3, 2, 1, 0, -1. Add 1 to -2. 2, -3. And now I have my new points. So plot them. -2, 4. -1, 0. 0, 3. -1, or I'm sorry, 1/2, 2. 1, 1. 1.5, 0. 2, -1. Kind of see that straight line going down through there. I skipped that. I must have skipped that next point. And then I got 2, -1. Hold on, did I do that right? Oh, 2, -1. That's good. That's my whole, though. That's my whole. That's my whole. See how I kind of have that whole? Yeah, I got to remember that. And then I got 2, 2. So 2, 2. That's my point. So that was this point over here. That's where it got moved to. Okay. And I skipped 3. I got 3, -3. 3, -3. So this starts my graph. It comes down, then it goes up, and then it comes down. It jumps the hole and comes down. I still have a linear, linear, linear. It used to be a positive slope, now it's a negative slope. This was a positive slope, now it's a, I'm sorry, this was a negative slope, now it's a positive. This was a positive, now it's a negative. The hole was way out here, it got cut in half. Then it got moved down. And it got, after it got reflected. So it got reflected, then it got in half, then it moved up. Some of you can do that without doing all those points. I just think it's easier for me. I might clean that up a little bit and make sure that that's a hole. Good. If that was a free response, I would want to make sure that that grader knows that I know that that's a hole. Bless. Okay, 2 times. The domain from example number 3 is -3 to 5. And the range is from 1 to 3. Find the domain of range of G where, so this is now G, again, kind of keep all this in mind. This was K. Okay, this was K. We got F, the domain of F from example 3. So I could go all the way back up to example number 3, right? Was that the graph? That was the graph. I don't think I need all that. I don't even think I need the graph because the domain was from -3 to 5. The range is from 1 to 3. Find the domain and range of the new one. So I like to multiply or divide before I do any addition and subtraction. I don't have any reflections because this is a positive. There's nothing in front of the x. So there's a vertical dilation by a factor of 2. That means all the vertical changes all the y values by a factor of 2. Okay? So now I'm going to go from 2 to 6. Right now, I'm not done. The x plus 3, it's with the x, plus 3, but it's opposite what you're thinking, so now it's minus 3. So now I'm going to subtract 3 from all of these. So now this will be negative 6, and this will be what, 2? And then I got a minus 4 out there all by itself, and the minus 4 all by itself changes the y's. So we're going to move that thing down 4 units. And so now instead of being 2, I'm going to move it down 4 units, which is negative 2, and move that down 4 units, and that puts it at 2. And now it wants my new domain and new range. So my new domain will be from x less than or equal to 2, greater than or equal to negative 6. And my range will be y, make sure we do y's and x's, less than or equal to 2, greater than or equal to negative 2. Yes, no, maybe? So we know how to do it with a graph. We know how to do it with just a function. Now we're going to do it with points, which we already know how to do with points because that's what I did with the graph. I just did it with the points. Example number 6. The table gives the values of the function p, x, p, at selected value. Let h of x be 3p, 2x, negative 1. Holy cow. Find the following values. H, H, H. So in other words, I got to transform this. They may trick you and ask you for a p. If they ask you for a p, it's really easy. We just go back up to here. Just recognize the little bitty things. So the 3p, that 3 is all by itself, so that's going to take all the y values and triple them. 3, negative 3, 0, 9, holy cow, 21. The 2x, 2 is with the x, so that's going to affect all the x's, opposite of what you think. So now it's 1/2. Half of negative 2 is negative 1. That's still 0. This is 1. Oh, that was so nice of them. 2, 3. And then the negative 1 just shifts everything down 1 unit. So now instead of this being 3, it's now going to be 2. This will be negative 4. This will be negative 1. This will be 8. And this will be 20. And now we can answer those 3 questions fairly easily. H of negative 1 is 2. H of 2, 8. H of 0, negative 4. Yes, no, maybe? Not too bad. You just gotta, if it's with the x, it affects the x. If it's not, it affects the y. The y is by itself. The x's are opposite of what you think. And then reflections over the x or over the y. Example 7. The function g is constructed by applying 3 transformations to the graph in this order. A horizontal dilation by a factor of 3. A vertical dilation by a factor of 4, and a vertical translation by negative 7 units. G of x equals a f b x plus C. I think this is a free response question. I just thought about that as I read this. Don't hold me to it. I'll let you know. Y'all remind me. Find the values of A, B, and C. Find the values of A, B, and C. So a horizontal dilation by a factor of 3. Horizontal, 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 horizontal is my x's. It's a dilation of 3. It's with the x's, so that means it's opposite of what we think. If it's a dilation of 3, that means B has to be 1/3. A vertical dilation by a factor of 4. Vertical's up and down. Vertical dilation of 4 just means a 4 all by itself. That has to mean that A is 4. And then a vertical translation by -7. I think we may put like plus C with the X and then plus D. Y'all okay? They're kind of helping you out with this one because you don't have anything with the X. So we're not even trying to trick you. Vertical translation by -7, so C must be -7. Easy enough? 2 more. I'm going to get y'all on the last one. So don't get too bored. Hopefully you're bored. Let K of X equal A, H, B, X, C, where A, B, and C are positive constraints in the XY plane. The graph of K is constructed by applying 3 transformations of the graph in this order. I'm going to go ahead and read the question before I keep going. Vertical dilation, vertical. Find K of -6. Okay? I got to find K of -6. Don't put -1 because that's what H of -6 is. So in this order, horizontal, 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 horizontal dilation of 1/2. Am I doubling or taking half? What's the value of B? Value of B is 2. If the value of B is 2, then what am I doing to all the X values? Taking 1/2. Y'all okay? Kind of see how we can do some things in here to make you think just a little bit. Okay, we typically think it's opposite, but this is already telling me it's the factor of 1/2. So I must be taking half of them all because B has to be 2. Okay, so I'm taking half of all these bad boys. -6, -3, -1.5, 0, 1.5. Vertical, vertical. I'm stopping. I'm not going to do all those others. Why? Because it asks for K of -6. -6, the first one. I'm not doing any other horizontal shifts. I'm done with all my horizontal shifts. So I don't care about anything after that one. Because all I care about is the -6. Y'all okay? If they asked for the 0, then I would have stopped and I would have just cared about that one. I don't have, you're trying to save myself some time here. I don't have to do all of them. So I did a horizontal dilation, a vertical dilation by a factor of 3. So now that's going to take this and make it a 3. And again, I don't have to do all of those. No need to. And then a vertical translation by 1. So I'm going to move that bad boy up 1. So instead of it being 3, I'm now going to be at 4. And so this will be 4. And all this up here, guys, shows your work. That shows your work. Okay, that shows your work. So picture that on a test, right? If that's a free response, you can't just have a naked answer down there. You got to see the work to get there. Okay, all right. This one here, this is going to get you. gets me every time, it's going to get you. Why are you not moving? Well, I still want you to go up. Turkey. Gobble, gobble. All right. Here I got a linear function. P of x is 3x minus 2. Okay. The graph of R is the image of P after a horizontal translation of 4. Is that all I'm doing to it? A horizontal translation of 4 to the graph of P. Find the values of A and B. Good enough? A horizontal translation of 4. Horizontal. Horizontal. Opposite of what you think. So if it's a horizontal translation of 4, then we know that we need a negative 4. And so this is where this is going to be tricky. And I don't know how to explain this other than I just got to explain it. Let's go here, red. Let's do red. Red for blood. I got 3x minus 2. Okay? Now, if you just do 3x minus 4 minus 2, that's where you're going to mess up. It's 3 and then x minus the 4. Because you have to somewhat just, let's put it in parentheses because anything with the parentheses affects the x. And then we have the minus the 2. And y'all can see now the difference between just putting a minus 4 and minus 2, because then you're going to put down b is negative 6. And b is not negative 6. B is negative 14. Because when I have a horizontal translation, I've already actually used that 3. That 3 has to be factored out. That 3 is kind of all by itself. That 3 is kind of by itself. It's with the x, it's tripled. I don't know. You just got to do it like this. I don't know how to explain it other than that's what you got to do. And so now A will still be 3. B will be negative 14. Okay? Yes? When I multiply this, when I distribute it now, I got 3x minus 12 minus 2. Okay? Sorry, I thought that was understood, but it's not because I saw a bunch of confused looks. I got to distribute that 3. So now the translation of the positive 4 with that 3 now makes it a negative 12. And then I'll put those two together to make the negative 14. Boy, I really hope I'm right. Y'all making me second guess it. I'm not. I'm right. I know I am. Oh, it's on the other page. Let's see. Where can I go to get that? Pre-cal. Unit 1. Oh, darn it. Unit 1. That was 1.12 notes. 1 notes. 112. Key. Beautiful. That looks just like ours. Beautiful. That looks just like ours. There's that stupid point. There's the new range. Yeah, negative 14. I knew what I was talking about. Wait, say it one more time. They just said find A and B, right? And don't have a naked answer. So show something on how you got it. You okay? So you kind of see how I got this. I should probably put that down here just to make sure, but that's enough. That's enough. They're going to put step by step by step. That's why I don't show their notes, because I think sometimes that's more confusing than it is. Really what they're looking for is this right here, but they don't want a naked answer all by itself. So just show something on how you got there. And you don't need to show this part because, I mean, that's not too hard of math. But if you need it, then show it.